Alright, so this is the chemistry lesson video for section 14.2, and this is going to be part 1. This section is all math, so I'm breaking it up into 2 videos just to kind of, it's going to be really long, so let's face it, you don't have to watch a 45-minute video in one sitting, so I'm just going to break it up into 2. So a long time ago, when I was student teaching, I realized that my students were having trouble remembering who said what gas laws, like who created each of the gas laws. So I wrote this a while back to help my students remember who did which laws. So it just says, Boyle is the VIP, Charles likes DirecTV, Gay and Lusac will TP the house directly next to me. So right now, I know that means nothing to you, but that's because you haven't learned any of the laws yet. And so as we go through each of the laws, I will explain what each statement means. Alright, so I would consider memorizing this though, because it makes your life a lot easier. Boyle is the VIP, Charles likes DirecTV, Gay and Lusac will TP the house directly next to me. And for those of you who don't know, because every now and then I get somebody who doesn't know this, TP is when you like toilet paper someone's house. Why some of y'all don't know that, I don't know. I guess y'all don't do that kind of stuff anymore. But anyway, so let's go ahead and jump in and do some of this math. So remember, our first statement says Boyle is the VIP. So I tried to color code everything for you. Boyle's law states that for a given mass of gas at constant temperature, the volume of the gas varies inversely or indirectly with pressure. So Boyle is the VIP. VIP means volume is inversely related to pressure. So that helps you remember who said that. It was Boyle. And what did he say? Volume is inversely related to pressure. What does inversely mean? Well, if volume doubles, pressure does the opposite. It cuts in half. So if volume goes down, pressure goes up, and vice versa. So if volume goes down, pressure goes up. And so his formula is P1 times V1 equals P2 times V2. So I'm just going to keep us a list of our formulas. There are a lot of formulas in this chapter, but remember, they'll all be on your formula sheet. So the ones just stand for the initials. So this is initial pressure times initial volume equals the final pressure times the final volume. And so that's all that's happening here. So if you're not good at rearranging formulas, you need to make sure you understand how to do that, because you're going to have to rearrange these every single time. So let's look at the first one together. So it says a balloon contains 30 liters of helium. So that's my V1. I know it's volume because it's liters. Volume will be in milliliters or liters. 30 liters of helium gas at 103 kPa. So that's my P1. Remember, our units for pressure are atmospheres, kilopascals, which is kPa, millimeters of mercury, and torr. What is the volume of helium? So I'm looking for V2. When the balloon rises to an altitude where pressure is only 25 kPa. So that is my pressure tube. Okay, if you will label everything in the questions like I did, it makes these so much easier. Alright, so I see my V's and my P's, so I know I'm using this formula. So let me write it over here. So I have P1 V1 equals P2 V2. I am solving for V2. When you are solving for something, you want it by itself on the equal sign. So that means I need to get P2 to the other side. I'll go over a quick reminder of how to do that, but otherwise you need to come to tutoring or ask me in class, because I'm not going to teach this every time we rearrange a formula in this lesson video. So you do the opposite mathematically. So right now it's P2 times V2. So to get P2 on the other side, I'm going to do the opposite of multiplying, which is dividing. So I'm going to divide by P2, but once you do that on one side, you have to do it on the other. And so then the P2's cancel on this side, so I'm left with V2 equals P1 V1 over P2. And then I'm ready to plug in. So I find my P1, so I've labeled it, so it's 103 kPa, times I find my V1, it is 30 liters. Over, I find my P2, it is 25 kilopascals. Now the only thing you need to make sure is you need to make sure your units cancel. So see how both pressures are in kilopascals? That's okay. If one was in kilopascals and one was in ATM, I would need to convert one of them. But my pressures do cancel. I'm left with liters, which is fine because it asked me for volume, which would be in liters. So I just do 103 times 30 divided by 25. And so when I do that, I get 123.6 liters. All right, and that's all you do for that one. So like I said, if you will label, I know in the beginning it seems like, well, why would I waste my time? Well, I don't think you understand how long this list of formulas is going to get. So if you label it, then you can figure out which formula to use. Because on the test, I'm not going to have a section that says, use Boyle's Law formula for these. You're going to have to figure out when to use which formula. All right, so let's move on and try a couple more, and then we'll move on to the next law. All right, so let's look at the top one. Unless you're feeling confident, you can pause it and try it. It says, the pressure on 2.5 liters. Now, a lot of you would call this P1 because you just saw pressure. But it says the pressure on 2.5 liters changes from this to this. So this is not the pressure. Liters is volume. Okay, so this is my V1. So the pressure on 2.5 liters of N2O changes from this, so there's my first pressure, 105 kPa is my P1, to 40.5 kPa, so there's my P2. If the temperature does not change, what will the new volume be? So there's my V2. All right, that's what I'm looking for. All right, so again, I see my P's and V's. I know I'm using Boyle's Law, so let me write that over here. So we have P1, V1 equals P2, V2. I'm solving for V2, so remember, I divide both sides by P2. So V2 is P1 times V1 over P2. And so then I just plug in, which is easy if you've already labeled everything. So P1 is 105 kPa times V1, which is 2.5 liters, over P2, which is 40.5 kPa. So again, my pressures are the same unit, so they're fine and they cancel out. Remember, if I gave you two different units, you would need to convert. So it's 105 times 2.5 divided by 40.5. And when I do that, I get 6.48, and my unit is liters because that's what I'm left with. All right, so if you haven't tried one, try this one on your own real quick, and then I'll assume you've done that. We'll look at it together. So it says a gas with a volume of 4 liters, so there's my V1, and a pressure of 205 kPa, so there's my P1, is allowed to expand to a volume of 12 liters, so there's my V2. What is the pressure, so I'm looking for P2, in the container if the temperature remains constant? Okay, so this time I have my V's and P's, but I'm looking for P2 this time. All right, so we know P1 times V1 equals P2 times V2. I'm looking for P2. So I need to divide both sides by V2 so that P2 can be by itself. So that's P1 times V1 over V2. And then I plug in since I've already labeled everything. So P1 is 205 kilopascals. V1 is 4 liters. And V2 is 12 liters. And so again, my units for liters cancel. If I had given you liters for one and milliliters for another, you would have needed to convert. So I just do 205 times 4 divided by 12, and I get 68.3, and the unit that I'm left with is kilopascals. All right, and so that's how you do Boyle's Law. So let's move on to our next one, which is Charles. And hopefully you got that one right. Hopefully you tried it on your own. I just have to assume you tried it because obviously I can't see you. All right. So we said Boyle is the VIP, so Boyle's Law says that volume is inversely related to pressure. The next line says Charles likes direct TV. So Charle's Law states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. All right, so Charles likes direct TV means temperature is directly proportional to volume. All right, and that's of the Kelvin temperature. You cannot use Celsius or Fahrenheit. All right, so what does directly mean? It means if temperature goes up, then volume goes up. Now, Charles' Law looks like this. It's volume 1 over temperature 1 equals volume 2 over temperature 2. The problem is some of y'all have trouble with solving for something in the denominator. I like to call you fractionally challenged. So if you are fractionally challenged, you can always cross multiply. So it would be V1 times T2 equals V2 times T1. Okay, and I'll do it that way in my lesson video because that's the way most of my students prefer. I prefer just to do it this way, but you know, whatever. And so again, your 1s just mean your initial values, your initial volume and temperature, and your 2s mean your final volume and temperature. Remember, you have to change temperature to Kelvin if it's in Celsius. So I gave you the friendly reminder of Kelvin is Celsius plus 273, in case you forgot that all the way back from chapter 3. All right, so again, Charles likes DirecTV just says temperature and volume are directly proportional, so they tend to do the same thing. If one goes up, the other goes up. If one goes down, the other goes down. So it says, a balloon inflated in a room at 24 degrees Celsius, so there's my T1. But what's wrong with it? It is in Celsius. So what do? I just add 273. So once you add 273 to 24, you get 297. It has a volume of 4 liters, so there's my V1. The balloon is then heated to a temperature of 58 degrees Celsius. So here's my T2, but again, it's in Celsius. So I just add 273 and I get 331 Kelvin. What is the new volume? So V2 question mark. All right. So the number one thing that people do wrong in Charles Law is they forget to change Celsius to Kelvin, or they mess up the formula, which I'll show you that in just a second. All right, so let's put our formula up here. So we see we have V's and T's, so we're using Charles Law. So V1 T2 equals V2 T1. We are solving for V2, which means to get it by itself, I divide both sides by T1. So V2 is V1 times T2 over T1. Okay, so I told you, common mistake is people forget to change Kelvin to Celsius to Kelvin. The other common mistake is plugging into your formula incorrectly. All right, so I start with V1, so I find that it's 4 liters. And then what does it say right here? It says times T2. Many of you will even write this on your paper, and then you will still plug in T1 for some reason, because you want the ones to be together. Well, everybody wants the ones to be together, but they're not together. It's a 1 and a 2 that's together this time. Okay, so you have to plug in T2. So it's V1 times T2, which I already labeled here, is 331 Kelvin. This is where, again, if you'll label everything in the question, it makes your life so much easier. Over T1. T1 is 297 Kelvin. So my Kelvins cancel. I'm left with liters, so I do 4 times 331 divided by 297. And when I do that, I get 4.46 liters. So like I said, there's 2 common mistakes. 1, people forget to change Celsius to Kelvin. And 2, even though you see the formula, you still do V1 times T1 over T2, even though that's not even what you have on your paper. Okay, follow what you have on your paper. All right, so let's look at a couple more. All right, so if you're feeling confident, you can go ahead and try this one on your own. Otherwise, watch me do this one, and then you can try the last one. So it says, if a sample of gas occupies 6.8 liters, so that's my V1, at 325 degrees Celsius. So there's my T1, but the problem is it's in degrees Celsius. So I need to add 273, and so I get 598 Kelvin. What will its volume be? So I'm looking for V2 at 25 degrees Celsius. So there's my T2, but again, I need to add 273. So I get 298 Kelvin if the pressure does not change. All right, so again, I see V's and T's, so I know I'm using Charles Law. So let's go ahead and rearrange. So we have V1 T2 equals V2 T1. I'm solving for V2, so to get it by itself, I divide both sides by T1. So V2 is V1 times T2 over T1. So now I'm ready to plug in. So my V1 is 6.8 liters. Now I know you want to multiply by T1, but you cannot. It is T2. My T2 is 298 Kelvin. Over my T1, which is 598 Kelvin. So those kelvins cancel. I'm left with liters, and so once I divide and multiply, I get 3.39 liters. And remember, all you do to solve these is you just do 6.8 times 298 divided by 598. Remember, same rule. Multiply across the top, divide across the bottom. All right, so if you haven't tried one, try this one, and then we'll look at it together and see if you got it right. All right, so it says exactly 5 liters, so that's my V1, of air at negative 50 degrees Celsius. So there's my T1. Now you gotta be careful, this is negative 50. So we still need to add 273, and so once we do that, we get 223. Is warmed to 100 degrees Celsius. So there's my T2, but of course, because it's Celsius, I need to add 273, so it becomes 373. What is the new volume? So we're looking for V2 again. All right, and just to let you know, for Charles Law, I noticed that I made you solve for V2 all 3 times. You don't always have to solve for V2. I just happened to randomly pick ones where you only solve for V2. So I see my V's and T's, so I know I'm using Charles Law, and I know I'm solving for V2. So to get it by itself, I have to divide both sides by T1. So V2 is V1 times T2 over T1 again. So I'm ready to plug in. So my V1 is 5 liters. My T2, remember, be careful, it's T2, is 373 Kelvin. Divided by my T1, which is 223 Kelvin. So those kelvins cancel, I'm left with liters, so I do 5 times 373 divided by 223, and I end up with 8.36 liters. All right, so hopefully you got that one right. So like I said, remember, for Charles Law, you have to have Kelvin, and don't deviate from what the formula says just because you want the ones to be together. All right, so we're going to stop here for our lesson video. So to get the rest of the laws, just watch part 2.